Welcome back, everyone, to another Up to the Time. Today we'll be looking at triangles. What is a triangle? A triangle is a closed, two-dimensional shape with three sides, three angles, and three vertices. A triangle is also a polygon. There are three types of triangle based on the length of the sides: equilateral, isosceles, and scalene. What is an equilateral triangle? An equilateral triangle is a triangle with all three sides of equal length. What is an scalene triangle? Scalene triangles are triangles with three sides of different lengths. What is an isosceles triangle? An isosceles triangle therefore has both two equal sides and two equal angles. Now, today we'll be looking at creating some triangles, but our triangles today would be a little more advanced than those that I just described. What is the altitude of going right? And what is the base? And what do all these things, these definitions mean when we are trying to create a triangle? So the base, what is the base? Any of the three sides of a triangle can be referred to as the base, as long as it is located horizontally, right? What is the altitude? The perpendicular distance from the base to the top vertex of the triangle. The altitude is sometimes referred to as the vertical height. So these are some terms that I just wanted to get out of the way before we proceed today. Just enlarging it, yeah. Triangle ABC, given the base and the base angles, let the base BC be 95 millimeter, angles ABC and ACB 60 degrees and 45 degrees respectively. So they give us a little bit of information on how we're going to draw this. So the first thing is we could draw BC because we know what BC is going to be here. Tell us BC is going to be 95. So we could draw this here, no problem. We know to create a 60-degree angle, and we know to create a 45-degree angle. So once we do that, we let each of those, and wherever they collide there, that is our A. So what we're going to do is we're going to reproduce that in CAD, and we're going to also take these dimensions too. What is the dimension of this side here? What is the dimension of this? And what is the dimension of that side? We're going to measure and put all three dimensions in. So that's how we're going to tackle that now. So let's start. So alpha line, and I'm going to draw a line, and I'm going to call it that line to be 95. That's 95. Let me just check. 95. And that is going to be BC. So you can put it MTX. Call that B. Just adjust this to 5. Yeah, let me just move this, copy. Oops, CO for copy. C. Cool. So that's BC. Now at B, we're going to create 60 degrees. Now, let me maximize this to show you different ways to create in this 60 degrees. You can come down here. You can set your polar tracking to 30, 60, 90, 120 degrees. And then you can come here, alpha line, and shift. That's at 30 degrees, so you don't want that. That's at 60 degrees, so hey, that's what we want, 60 degrees. And while doing that, you can specify the distance that you want. Or if you just don't want distance, you can just drag it right through 60 degrees. So we can just do that. That's one way you can create your 60 degrees. Another way you can create your 60 degrees is to press tab. But my tab doesn't seem to be working. So what I would do is I would press the shift and place the less than symbol and put in 60 degrees. And then when I press enter, it would just turn to 60 degrees. That's what I normally do. All right. So you can use this polar tracking, or you can use the shift and less than symbol. Okay, so that's in at 60 degrees. Let me just move this out of the way and bring that down here. All right, and now this other one is going to go in at 45 degrees here. So we can do that. Sure. Okay, the 45 is going on this side. So what I really wanted was 135. But what I'm going to do is I'm just going to mirror it. And erase the source object. So that right here where it intersects is my A. So I'm going to copy and put my A in. A. What I'm going to do is draw circles at each point. I'm going to trim them so you can see the angles. Angle there. It says total angle. That's 45. Okay. Here, that's 60. Here, that's 75. All right. So that's one way we can see the angles. Let's just put that in. Let me close this menu. Let me put that in. Option degrees. Okay. So that's that. So this is triangle one done, actually. But let me label it so that I would know. So I'm going to move this over to here. I'm going to label what this is. 5 mil, 60 degrees, and 45. So that one is done. So now we're going to move on to the second one. Let me see, is this the second one? Yep, this is the second one. So let's read this one. Triangle ABC, given the altitude and two base angles, let the altitude be 45 mil and the base angles ABC and ACB 30 degrees and 45 degrees respectively. So let's look at their strategy. Draw horizontal lines DE and FG 45 millimeters apart. Okay, so what that means is we're going to start off with this line here, and then we're going to offset this up to get this line here, 45 mil. All right, that's what we're going to do. That's the first thing. And where it says ABC is 30. So we know that this is here got to be A. This is B, as they have there, and that's C. So that means the 30 degrees we know to create that 30 degrees there. So select a convenient point A on FG, okay, which is here. So let me just clear this and put back this line. So we're gonna select this point A on FG. Draw angle HAF 30 degrees. So H, which is down here, A, F, where is F? Okay, which is here. So the angle is going here. So it's the angle in here that is going to be 30 degrees. All right? This is going to be 30 degrees here in this point here. So we're going to draw this angle here. Yeah, first. That's the first thing we're going to do. At 30 degrees. So when we do that, and then we're going to draw IAG. So where's I? I, A, and G. So then we're going to come out here and draw this one here at 45 degrees. Yep. And that's the second thing we're going to do. And that would then, we go to HA, which is here and here, and IA, intersect DE. So what they're saying is that after we have created these two angles at 1 and 2, whereas this hits this line and that hits this line, we would then get our triangle here. All right. So let's give this a try. So the first thing is, let's get these two parallel lines on the board. So my first line is going to be a random line down here, put on my ortho of any length, right? That's a good length there, I think. And I'm going to offset this 45 mil up. Good. And I'm going to pick a point, a random point on the line. So I pick that point there. Let me turn on my point. UDP. Return it to here. Return it to 3. Okay, good. So that's my point, and I'm going to call that A. So I'm going to grab a text from here and call this A. Call that A. Now, what's the next thing I'm going to do? I'm going to now create a 30 degree right here. So I know the easiest thing is to create a 30 degree above here and then mirror it and get it below. That's what I'm going to do. All right. That's the easiest thing to do. So I create a 30 degree. Let me go shift 30. Yeah, and I know I need to mirror this. Probably need to mirror it twice. Need to mirror onto that track, yes. And then I need to mirror it down below here now. All right, on this track. So then go here. So I did that purposely to show people that even if you don't know to get a 30 degree in this direction, you can go through that technique because it's a 30 degree in any direction, right? So that's why I did that. Now, so where it hits here, that's our B. So I can put here, copy, and I can move that and call that intersection point B. And then now what I need to do is I need to go over to my C, and I'm going to create a 45 degree. line here. Because the whole concept is wherever 45 is, and you just mirror it, you will get back 45. So despite I am creating my 45-degree above board, now I'm going to mirror this. And I'm mirroring it in this direction. And I get my 45 going in this below direction. Now I'm going to extend. And that's my 45. And that's point C. Right. So that's how we have basically created this. So the technique that was used is I created a 45 and I created a 30-degree here at this junction, right? And then that is transferred down here at this junction because these lines are parallel, right? So when I go here, copy this. You know the angle here? Let me test the angle. The angle is 45 right here. 45 total angle. And you know the angle down here also? You just select it, it's 45, right? So that's an interesting geometry trick if you've never seen it before. The angle on this side here is 30. So this triangle was done by, let me move this over here. This was done by me given the base, me given the altitude and two base angles, all right? So that is the title for this one. Okay, so what's the altitude? The altitude would be 45 mil, and two base angles would be 30 degrees and 45 degrees. Given altitude and two base angles. So that's that there, right? So let's go to this one now, where the triangle given the base. Okay, so let me increase this. As we read, triangle given the base, altitude, and vertical angle. Let the base BC be 105 millimeter long, the altitude 35 millimeter, and the vertical angle 60 degrees. In long and short, is we start off with what I will call a construction angle down here, which is 60 degrees. That is a construction angle. So just put construct. You see. Okay. Construct, and then we transfer that angle here. Real angle to create the triangle, right? REAL. The R, more like that. So this is the strategy, but I'll be going through this bit by bit, just in case that it didn't make any sense when I was reading it. Now let us get to work here. So I'm going to come outside for this one and hit L and draw a horizontal line and make my horizontal line Let the base BC be 105. So make that 105. Okay, that's my horizontal line. Call it BC. So let me grab a text. B C B B move. Good. No, let me just save this. Forgot to save. Cool. After that, they want me to make an altitude of 35 mil up. So you're gonna offset 35 mil up. 35. Yep, that's 35 mil up. And that line goes further. Let's just imagine this line goes a little further like that. And that line is called F and G, right? So we call that G, call that F. That is 35 mil, right? Let me just put that there. 35 mil up. Now, what do we need to do? Draw angle EBD at 60 degrees. So this angle, which is going to be here, E going to B, and then coming down here at D is 60 degrees. So we're going to do that similarly to how we did the last one. Alpha line, and I just create my 60 degrees there. I'll put it in this direction, so you just have to mirror it once. Erase, so yeah. So that's my 60 degrees there. Now, what they're saying is after that, let's clear it. No, should I clear that? Yeah, I'll clear that. And let's go again now to read this. Bisect the line BC. So that means I'm going to come here and I'm going to find half. So I'm going to find half right here. But the problem is now with this that I did, which I didn't like, is that I had the distance of this line one time, but I stretched the line so to find E, which I didn't think was necessary in the whole construction, but whatever. What is the distance of this line now? BC. Let me get back the distance. The distance is 105. So what I'm going to do is create a circle here. And where it hits 105, pivot not, that's my trimming point. Or I could break it. I could break my line here and put it to here, go back to there, and get rid of my circle. So that's my 105. So now I can find my halfway line by just hovering over the half, and that's my bisector. Right, so you can find a halfway line and just send this up. I'll probably put this in a construction. Oh, yeah. And this one down here in construction. And this one in outline. Start to make this look tidy at this point. So now what I'm going to do, after I've done that, is to erect a perpendicular to BD at B. Okay. All right. So what I want is at this point here, right? I create a 90 degrees at this point there. They want that. All right, that's not a problem. So in order for me to do that, I'll create just that 90 degrees. So I know how to do that. I know that I can come here and create a circle, right? And trim it. And this is half of 180 is 90 degrees, because right now this line is 180. So that's my 90 degrees there, right? So that is my perpendicular line. And I can copy that right to here, right? And that is my parallel, because the two of these are parallel. So now what I can do is I can then extend this line to hit here. Ah, see? That's what I was extended. So that's how that intersects there. And that gives me point O. So now I'm going to, you know what? I will keep this construction. And I would copy it and put it over here. I'll call that up as 90 degrees later on. Let me just move B out of the way. Right. So now I'm going to call this point O. That's point O there. And what I'm going to do is, what's the next thing now? Okay. So, right, the bisectors intersect the perpendicular to BD at O. So we have established O. So using O as center, we're going to create a circle. So you're going to hit C and use O as my center here. And open it to B and create a circle. Cool. So the circle touches both B and C. Perfect. All right. Now, what is the next thing now that I need to draw? Draw. All I had to know, really and truly, is that FG intersects the circle at this point. That's all I had to know. All right. So once I get to that point there, I could then draw a line to B. And they're saying that there, once I get to that point, I can also draw a line then to C. Because I would have had the last point to make this triangle. So let's go. All right. So let us prove our little something here. We know that these two construction lines, that is our 90 degree right here, right? Let me just put that. Call that up as 90 degrees. But yet the angle in here, that is supposed to be 60 degrees. So let's put that down here. That's 60 degrees, right? And they're saying the angle here has to be 60 degrees. So let's open this now. And let us check this angle. Total angle, 60 degrees. Just editing at this point. This was triangle ABC given the base, altitude, and vertical angle. So this is triangle given base, altitude, and vertical angle. One angle they give you. So the base, base was 105, 105. Altitude, altitude was 35 mil. And the last thing was the angle. So, right. Yeah. So that's 3 done. Let's look for this other one. So this other one, let's have a look here. This is triangle ABC. Given the perimeter and the ratio of the length of sides, let the perimeter be 120 mil and the ratio of the length of the sides 2, 3, 4. Okay, so let's look at the strategy. Draw a line to DC, DE 120 mil long. So this is 120 mil to there. That's the first thing. And then they're going to ask you to divide this line into a ratio of 2, 3, and 4. Now what this means exactly is that you need to add these numbers and get a total. So when you add 2 to 3, you get 5. And you add 5 to 4, you get 9. So these are 9 strokes here. 1, 2. So secondly, you need to come up with a construction line at any angle starting from D and going. So I'm just going to put mine like that to show it's a random angle. And then you need to create a distance between your first point and your second point and hold that distance, make sure it's equal, and make 9 equal distances along this line using that initial distance. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Of course, mine aren't equal. And then the last point, you connect it to E. And then you're going to make tracks to the various points that you need to stop. So the various points that we're going to need to stop and create track lines are at 2 and 3. So we're going to count the first 2 down, right? And then we're going to put in a point there. So that'd be 1, 2, which should be here. And you put a track point there, which is a track meaning a parallel track here. Would be a parallel track there, right? A parallel track there. And then we will come to 4, my bad, 3. 3 at that point. So let me just undo that. So we will start the sequence again at 0 and go 1, 2, 3, right? So when we get to this point, we would then parallel track. So that's a parallel track again, all starting from this first parallel, from this line here, which is to E. Right, so that's how we would get BC first. And then what we're gonna do is we're gonna then come here at C, and open up a compass to there and get this arc along here. And then we will come at B, open up a compass to there and get that arc and where they intersect. That's how we're gonna get our triangle there. So let's come here and let's try that. So the first thing is I'm going to get the line up on the board, which is D to E 120. The E 120. And then we're going to put our construction line down here. Take off the ortho. Yeah, just do it that. And then what I'm going to do is I'm going to divide this into 2 plus 3 is 5, 5 plus 4 is 9, into 9 parts. Right? The IV Go there, type 9. That's my 9 parts there on the line. And my last part here, let me count them 1, 2, 3, 4, 5, 6, 7, 8, 9. That always amazes me. 9 is to there. So now anytime I want to, I can bring it to the ones that I need to bring it to. So I need to bring it to the first one, second one. 1, 2. So this one is what I'm going to do. I'm going to copy the number 2 down. 1, 2. Boom. And let's move now. Now we need to move this to 3. So we go 1, 2, 3. 3 here. And then the last one is going to be 4. 1, 2, 3, 4. So the last one at the end is going to be 4. So that's how we have distributed the ratio there to answer the question. All right. So now what we're going to do is parallel track, which is, in a sense, copying. I'm just going to copy this over to 3 and this over to 2. And I'm going to trim. And these points here become now my D, sorry, my B and my C. My C and my B. Right? Now I'm going to come here and open up my compass at C to E. And then do the same thing at B to D. And where they intersect right here at this point, which I'm going to put a point. I can trim now. So what I'm going to do is also put a circle and then trim around it so that you can see the construction, right? Or let me think of a nice way to present this. Given the perimeter and the ratio of the length of sides, right? So what was the perimeter of sides? CID, 120 mil perimeter meter and 2 to 3 to 4. All right. Let me take down my points. I don't think I need them anymore. And that's done there. And I think we need to do one more. Yeah. And then we'll be finished. But what I can do at this stage is I can dimension at this stage before we go on to the last one. So it's 40. Let me align these dimensions. That's the 105. Yeah. 95. All right, cool. So we can move on to the last problem now. Triangle ABC, given the base and the angles in a given ratio. Let the base BC be 90 mil long and the ratio 345. All right, so draw horizontal line BC and produce D. To D. All right, let's follow along. So you start off with BC. Then you got here C. You create a semicircle. And you divide the circle into 12 parts, right? 12 parts, however. 12. Right? And then you do a similar thing. You actually identify these points 3, 4, and 5 in the ratio, because this is what is given 3, 4, and 5. So you identify which this is 3, this is the, yeah, and that's it, right? So you identify those, and from those you create connections to C. So you would create a connection here and a connection there. And we would do is just extend this connection. And then you would create that connection there and extend that connection. And then what you would do is you would track this line over to here to get this line, because this line and that line are parallel. And that's how we would get our whole point A here. All right, so that's the strategy. Let's get to doing it now. Let BC be 90. So I'm going to put that at 90. And let me call it B. Copy. BC be 90. And what we're going to do at this stage now is we're going to come here at C. And we're going to create a circle. But we're going to add on this line here, right? So these are construction lines. Probably going to construction there. That'll make a lot of sense. And now what I'm going to do is trim this, right? Because I want a half circle. That's what I want. And now I'm going to divide this into 12. So div, and then they ask me how many, enter the number of segments. I'm going to type in 12. And why am I not saying anything? Because I remember turning off my points. So I'm going to put my points at about 2. That looks pretty cool. And now I'm going to identify the points that I need. So I am going to grab this number here. That's it for the ratio that I need. I need 3. So this will be 1, 2, 3. So I need this one there, 3, but 3 looks close to 2. So let me move 3 and put 3 there. Yeah. 1, 2, 3, 3. And the next one that I need is 4. So that is 1, 2, 3, 4. Right. So this is 4. Right. And then the last one that I need is 5. 1, 2, 3, 4, 5. So 5 gets a spot. And 5 is division. All right. So how this is going to work now is that I'm going to send a line from C to 3. And I'm going to Just imagine I have a line out here, just some back line. And I'm just going to extend 3 to that line, right? Yeah, good. Cool. That's it. Now I'm going to do from C to 4. And I'm going to do the same thing now. Just draw some back line here and extend this. EX to extend. Right. And now this is where we're going to track this line over here to point B. Right. And when they intersect right here, this is how I get my point A. So I'll put that in there as A. Right. So what I'm going to do is break these lines. Why do I break these lines? So that when I'm match dropping, I can get my triangle lines and still retain my construction lines as a separate line, all stemming from one point. All right. So that is how we will create. Yeah, that's how you create the last one, which is a triangle ABC given the base and the angles in a given ratio. So let me just place this over here now. And I'm going to place a dimension on here. There's 90. Remember that? There's 90. Yep. And if anybody wanted to, you can just construct this and find what is the angle there at 3 and so forth, and see if they correspond to the angle at 4, 3, 4, and then the angle at 4 to 5, if they're matching by the angles within the triangle here, right? You can do that. Triangle given the base and triangle given base and the angles in a given ratio. So what is the base? The base was 90 long, 90 mil long base. Ratio was 3, 4 to 5. And when you add those 3 numbers, you get 12. So that's why we divided this into 12, right? So this brings us to the end. So let's recap. Today we learned about triangles, what a triangle is, and the different types of triangles you can have. You can have 3 different types of triangles: equilateral triangle, isosceles triangle, and scalene triangle. We didn't spend much time on those, but we did 5 different triangle problems today. We did a problem. The first one was triangle given base and base angles. The base angles were 60 and 45 degrees respectively, and the base was 95 mil. Let me just bring this further down so that breathes better. All right, the second problem we tackled was a triangle given altitude and 2 base angles. So the altitude was for this one was 45 mil, and the 2 base angles were 35 degrees and 45 degrees respectively. Let me just place the altitude there. The correct layer, 45. Good. Let's move on to the third one. The third one we did was a triangle given the base, altitude, and vertical angles. Base was 105 mil, and the altitude was 35 mil, and the angle was 30 degrees. No, this angle wasn't 30 degrees, it was 60 degrees. Let's just correct this now. 60 degrees. This one over here, triangle given the base, the perimeter, and the ratio of the length of side. The length of the entire side we started off with was 120 mil. Put that under here. And the ratio that we split this line into was 2 to 3 to 4. That's it there. Yeah, good. This last one, triangle given the base and the angles in a given ratio. 90 mil was the base, and the ratio was 3 to 4 to 5. So what we did is we created the construction line, and then we created the ratio within the angle here, 3, 4, 5. All right. Let me turn off my points. Put them back there to that. And thanks for joining. This brings us to the end. I would like to encourage each and every one of you to practice this simple geometry exercise, how to draw triangles using and taking different information. Also, like, share, and subscribe to the channel to see more interesting geometry exercises. I am out.